Hey, this is a retry on the video. Turns out my microphone is broken, so we're going to try it again. I hope you can hear me this time. You should have been able to follow along with the other video without some sound, but we will try to quickly go through it again. First of all, what we're going to be talking about is absolute value. The distance from 0 on a number line is always positive. Okay, so refresher from back in the day. The absolute value of 5 is equal to 5. The absolute value of a negative 5 is also equal to 5. Absolute value will never be equal to a negative. Okay? So here we go. Since the inside of this equation can be 22 or a negative 22, when we solve absolute value equations, what we need to do is set the inside equal to the positive and equal to the negative. So that way, when we solve it, we will have both of our possible values for what goes inside of the absolute value. So for the first one, we're going to get m equals 3. And for our second term, we're going to get a negative 29/5. Okay, so if we were to plug both of those back into m inside of our absolute value equation, we would get 22 for both, so they are both correct. Now, number 2, first thing you're going to do is subtract your 16. You have to get the absolute value by itself first before you separate. Divide by the 4. And right here, you should see a little bit of an issue. Earlier we said that the absolute value of 5 is equal to 5 and the absolute value of a negative 5 is equal to 5. We are never going to have an absolute value equal to a negative. So, is the absolute value of 3m plus 1 ever going to be equal to a negative 2? The answer is no. So this one has no solution. Feel free to pause and try number 3 on your own. So how do we feel? Did you guys get x equals 6 and 12? Yeah, you probably thought the sound was gone again, huh? Okay, so there we go. If you have any questions about that, feel free to ask tomorrow. Okay, so solving and graphing absolute value inequalities. The other day we talked about inequalities and compound inequalities specifically and in OR statements. Absolute value inequalities are either going to be an AND statement or an OR statement. How can you tell? Well, you can tell by the direction of the symbol. If it's a less than symbol, let's say less than. Anytime it's a less than symbol in an absolute value inequality, it's going to be an AND statement. For number 5, when it's greater, we can just say that it's greater. Okay, so anytime you have a greater than statement, it is an OR statement. Okay, so then solving it, it's very similar. We're going to take the 23 minus 2x is less than 17, and 23 minus 2x is greater than a negative 17. So like absolute value equations, we still have to set it equal to the positive and the negative. However, when we set it equal to the negative, we have to change the direction of the inequality sign as well. So now we just solve it like we did the other day with our inequalities. So we're going to have a negative 2x is less than a negative 6. So x is greater than 3. because we have to change the direction of the sign when we divide by a negative. And we have a negative 2x is greater than a negative 40. So x is less than 20. And we just graph our inequality like we did the other day. We've got our 0, our 3, our 20. X is greater than 3. X is less than 20. And an AND statement is supposed to look like that. So there's our three-tiered method, just like from the other day. Take a minute to try number 5 on your own. It's an OR statement. So that's the first part of it. You have to add the 9 to the other side first. So now what we do is we take our inside and we set it greater than or equal to 7 and less than or equal to a negative 7. This is an OR statement. Solve both of them. So x is greater than or equal to 1/2, or x is less than or equal to a negative 3. So we'll just graph it again. We've got our 0. No, we don't. We have our negative 3, 0, and 1/2. X is greater than or equal to 1/2. X is less than or equal to negative 3. We do not need a third tier because that is what an OR statement is supposed to look like. Okay. Models for tolerance. Models for tolerance are going to be given to you on a quiz or a test, okay? So on your test next week, the actual minus ideal absolute value is less than or equal to the tolerance. That will be given to you. You will not have to memorize that equation. So a manufacturer has a 0.6 ounce tolerance for a bottle of salad dressing advertised as 16 ounces. Write and solve the absolute value inequality that describes the acceptable values or volumes for the 16-ounce bottles. Okay, so the actual minus the ideal is less than or equal to the tolerance. Okay, so the actual we don't know yet because it can vary. Minus the ideal, which is 16 ounces, is less than or equal to the tolerance, is 0.6. Okay, so this is a less than statement. So x minus 16 is less than or equal to 0.6, and x minus 16 is greater than or equal to 0.6. Solve both of them. So x is less than or equal to 16.6 ounces, and x is greater than or equal to, I'm sorry, this was supposed to have a negative 0.6, greater than or equal to 15.4 ounces. Okay, so anything between 15.4 and 16.6 ounces would be acceptable. Anything outside of that range would not be approved by this company. Okay. Number 7. A city ordinance states that pools must be enhanced by a fence that is from 3 feet to 6 feet high. Write an absolute value inequality describing the fences that don't meet this ordinance. Okay, so there's another tolerance model. It's the actual minus the average of extremes, which is greater than the tolerance. Okay, so let h be the height of the fence. What's the average of the extremes? Well, our extremes is 3 and 6. Divide that by 2. The average of our extremes is 4.5. Okay, the tolerance. Our tolerance is, let's think about this. Our tolerance is going to have to be, if that's the average, all you have to do is take one of your extremes, we'll say 6, and subtract the average. Our tolerance is 1.5. So we're going to write an inequality that describes the fences that don't meet this ordinance. Okay, so we have the actual, again, we don't know, minus the average of the extremes, which we said is 4.5, which is greater than the tolerance of 1.5. This is an OR statement, so we're going to have x minus 4.5 is greater than 1.5, or x minus 4.5 is less than a negative 1.5. All you have to do is add your 4.5, x is greater than 6, or add your 4.5, x is less than 3. And of course, this is feet. And that will tell you the range of which is not acceptable by the city ordinance for the height of a fence around the pool. Okay, so I understand we went through these notes a little quick. I just wanted to try to get something up here for you guys as quick as possible since the last video didn't have audio. I need to look into getting a new microphone, so if this sounds a little shaky, I apologize. Have a good night.